is John Zane, and today I'll be presenting my project on the essay that I wrote, which is a real-time multiplayer FPS game using 3D modeling and AI machine learning. So to begin, for introductions, so first, when we think about entertainment, there are a variety of ways to have fun, such as music, sports, and movies, right? But due to COVID-19, and many people are being forced to engage in self-quarantine, and so because of this, the video game industry giants such as Riot Games, Blizzard, and Epic Games have all tried to produce new games for its audiences in order to maximize their profit during this crucial time of opportunities to flourish. And one of the most popular game genres are what is known as first-person shooters or FPS games. These games are popular among especially teenagers who enjoy the combat experience of playing in the three-dimensional world through the eyes of the character model. And so the Maze Escape game's purpose is to explore the wide range of tools that are available for developing AIs in video games in an attempt to select the best solutions for creating the multiplayer experiences. So the development of the game. So some of the existing AI techniques and systems that have been proposed include NavMesh for AI pathfinding, reactive systems such as finite state machines, and behavior trees. So I'm going to be explaining each one by one. So first, let's talk about NavMesh. NavMesh is a technique that is using constructs a mesh from which AI is able to determine the best path from getting from one point to another, as well as providing a way to kind of like see the environment around the AI. The reactive system allowed the AI to sorry, allows the AI to interact with the player's decisions and take different actions to create different experiences for the player. And finite state machines or FSMs achieves this by having different states that the AI can be in to match different existing scenarios in the game, such as you can be in combat or you can be running around, etc. While behavior trees achieves this by having a set of rules and conditions to guide the decision-making process. Next, the set of methods that we have used for the game include NavMesh system and waypoint systems. So first, the NavMesh system allows for pathfinding inside the level generator, which prevents the player from walking straight through walls and objects in the environment. And the waypoint system allows for the escape robot to have an unpredictable route for reaching the end goal, which would imitate that of a real player style of playing the game, which is filled with randomness and does not conform to a fixed way of playing the game. So next, there are two application scenarios. So in these two application scenarios, we demonstrate how the above combination of techniques increases the accuracy or the imitation for the ability of the AI to mimic the multiplayer experience. So first, we demonstrate the usefulness of our approach by a comprehensive case study on the competitive AI compared to the competitive player, in which the player has to play against one other opponent, either AI or another player, in a 1v1 game mode, in which one acts as the defender and the other as the escaper. And this will make more sense when we get to the demo video on what these terms are. And second, we try to analyze the result of our 1v1 competitive AI versus competitive player with the cooperative AI compared to a cooperative player. In this case, not only are we testing the player's experience by playing against an opponent AI and seeing the differences between an actual person and the AI, we're also implementing a way for the player to play with an ally in the game, either AI or another player against two opponents in a 2v2 format. And of course, lastly, we can test our results through a questionnaire by asking the player's experiences playing the game with the AI versus that of an actual person. And therefore, by measuring the level of artificial intelligence imitation that has been achieved, we're able to verify whether or not the performance of each of the AIs, both the competitive version and cooperative, have been enhanced in order to emulate the real online multiplayer experience. So the challenges that we faced. So the first are net first to start off, the first challenge that we encounter has to do with networking. For instance, in order to create the game, we need to first figure out which Unity networking solutions to use, which is difficult as creating custom networking scripts is much more difficult and challenging compared to using a pre-built solution that requires no coding and programming. Next was setting up the player. We had trouble determining the location of the spawn points and had issues with the player not spawning in the right locations. Also, there were errors in the camera FOV in which the character model's eyes will see the interior of the gun that blocks off its vision, and also the control as well. Um, and also the controls as well when the player spawn and not be controlling its own character. And there were also errors in the movement and shooting as well. And lastly, setting up teams required the creation of the teams, and in order to keep each side balanced and assign bots accordingly, or the game will not start. Next was the nav mesh system. So first, first we are required to find how to create the nav mesh on top of a level. It was difficult because it was difficult to dynamically generate the nav mesh during the game because as when generating a new level, the nav mesh will not change, and the problem with that is the inability to produce an accurate path that matches the level produced by the procedural maze generator that we implemented at the beginning of the game. We had trouble getting the bots to use the newly produced NavMesh as we couldn't figure out how to get the AI to walk with the player model, and using NavMesh agent for walking as it required a separate animator component for AI movement to allow the bot to play the walking animation. And lastly, we had to program the code for the escaper bot waypoint list and randomly choose one point to go to before heading to the end goal in which we designed to allow randomness for the path chosen, just like that of a real player. The third challenge is our AI behaviors. So there was an issue with the escaper bots not moving to the end goal and also choosing the same path despite the random waypoints that were designed to prevent fixed AI behaviors from occurring. Next, there was also a movement issue with the defender bots as they were unresponsive and remained standing throughout the duration of the game, and we had difficulty adding the wandering system to have them move around the level. And the last two issues were for the escapers not trying to run away from the defender when it opened to its field of view, and it decided to just run past it. And lastly, with the bots not shooting when the opponent player was facing them as it entered its shooting radius. So the solutions. So for the overall system to begin, it starts with the menu section, which includes the ability for the user to log in, of course, with the name, then join a game room or create their own and choose their own team. And after their initial process, the host of the game will start the game once every user is ready, and the host will also check if any kinds of bots in the game are added. Next, the Maze Escape is a strategic multiplayer FPS game in which players are deployed into a virtual 3D world and are divided into two teams, the defender and the escapers. And because of its competitive nature, um, in order for both to achieve victory, they will need to satisfy their unique winning conditions. For instance, the defenders needs to, um, sorry, losing voice here. The defender needs to either eliminate all escapers or keep them occupied until the timer hits 0 in order to win. On the other hand, the escapers are able to either kill all defenders or try to avoid them and escape the maze to achieve victory. And for the game engine, we just decided to use Unity as it is the most efficient and easiest. Okay, for pathfinding. So after this, we're able to implement the AI navigation mesh and waypoint system for pathfinding, and also later adding shooting mechanics, animations for the AIs, and AI health bar in order to recreate the experience of that of a real player, which is basically the purpose of this game. Next was the Photon networking system. So furthermore, in the game level, we implemented networking by adding specific components to synchronize player position, health, and any animations that are playing. The game level has a component for handling the player and bot spawning, which has lists which has a list of points where each team can spawn in, as well as a randomizer function to allow the positions to be randomized. We also added a game manager system on top of this for synchronizing the time left for the round and the amount of players remaining for every single player in the lobby. And in addition, we have added a script for handling the end goal for the escapers, which is a simple trigger which will determine whether the escaper has entered the escaping zone, and if true, it will display on the screen for all the players that the escapers have won. So AI behaviors. There are two sides to the NavMesh system. So first, the NavMesh level component will generate all the pathways from one point in the level to another. And the second, which is the NavMesh agent, the AI Pathfinder, it uses the generated mesh to determine the optimal path from one point in the level to another. With these two components, the escaper bots are able to find a path to reach the angle because the NavMesh agent will choose the optimal path, which is usually the shortest path, and the escaper bots tend to always choose the same path, resulting in predictable behavior. So we're trying to avoid that. We're trying to recreate the multiplayer experience. To remedy this issue, the waypoint system is administered to each escaper bot with a random waypoint, so that the AI has to go to before reaching the end goal. And this also allowed the defender boss to randomly choose a waypoint to patrol that area. And this is a demo video that I'll be showing you guys the game. So here's the Maze Escape main menu system. Here I click play, and it takes us to the game lobby system where you can choose your teams and etc. You can be defender or escapers. You have the roles, which we will add later on in the future, and you can also add the number of bots you desire to be spawned into your game. And there's also colors to indicate which side you're on. And yeah, you can press start the game. Right, and so this bot right here, with the green health bar, this is our teammate, and I think we're pretty sure we're the escapers, so we're trying to reach the end goal, which is in that little cube right there. So once in that little blue bot with the blue health bar is the escaper. So we're trying to reach the end goal in order to satisfy the winning condition. So after it's reached, you can see escapers win. And just reset. So we can also win by shooting the enemy bot. So once we shoot that, we also win. And another one I didn't mention was if the timer hits 0. So if you see if the timer hits 0 and you guys don't satisfy any of the winning conditions, like killing the enemies or reaching the end goal, the defenders will automatically win because the time had run out. And that's basically it. All right. So in conclusion, so in order to enhance the multiplayer experience, we can replicate the behaviors from that of a real player onto the AI through using a list of methodologies, which enables the AI to have human functions that is distinct from that of the AI experience. And Maze Escape is excellent in determining the optimal solution for combining the multiplayer experience with AI. And escapers and defenders all have its unique goals. And for future development, of course, we'll be adding role systems such as like the player can choose either to be close range, middle range, or long range. And we also be adding additional maps, weapons, and abilities. And for the AI updates, we'll be including decision trees, behavior trees, and planner systems. And that is going to be the end. Thank you guys.